Are we definitely live, yeah?
We're live, the sound, we can see a screen. Right, from the top, introducing Gareth Kerr, who's going to talk about Sencode Breaches, Life's a Breach. Let's go.
Thank you very much. So hello guys, my name is Gareth Kerr. I work as a web app pen tester for Sencode Cybersecurity. I'm also OSCP certified, and I'm one of the unlucky people who did a cybersecurity degree. I know they're quite controversial. A little bit about my history. So I spent too long working in tech support, developed passive-aggressive sarcasm syndrome as a result of that, and I moved into security around about 4 years ago. I enjoy climbing and bouldering as well. If I'm not at my computer, I'm usually at a bouldering wall. Hacking all the things, of course, web development and blue light tanning beds. I find that 4 monitors works best for that. So why am I talking to you today? So I'll discuss a research project on the exploit.in data breach collection. So the why and how, the results and future work, and also Sencode Breaches, so the application that I've made, why I made Have I Been Pawned version 2, the unwanted version, and future development for that as well. So research, so how was the research done? So originally this idea came from Morphus Labs. So they'd previously done passed out passwords, data breaches into the ELK stack and analyzed the data for this. So it's essentially, I've done exactly the same thing. And the reason I did that is essentially I wanted to see how effective password masks were created using this method. So I used Python to parse out 110 text files, which contained 789 million passwords. Using the ELK stack, which is comprised of Elasticsearch, Logstash, and Kibana. I only actually used Elasticsearch and Kibana because I did the parsing and everything else with Python. So that was to perform the data analysis. And the purpose of the research was to see if it was effective, as I said, to produce password masks from the data and whether they're any good. So the ELK stack, if you're not familiar with what that is, it's Elasticsearch, which allows us to index items, essentially. In this case, we're indexing large data breach files. And Kibana, so that works as visualization platform. It also has machine learning baked into it now, and that uses the Apache Lucian syntax, query syntax, to create complex aggregations. And Logstash wasn't actually used in this research. As I said, I used Python for that. So how was it done, and what did the data look like? Well, each entry in the text file looked something like this. So it would be some email at some domain and some password. So every line was formatted like this. So what we did is use some Python code to parse it out. So the code parses that line, chunks it into chunks of data that are useful for complex querying. So the table shows the data configuration for it. So we've got the user, which would be the email address, the password, very secure password 123, the domain, the length of the password. This is the important bit here, which is the password mask. And this is the hashcat mask formatting. So it'll be uppercase, 7 lowercase, 3 digits. And that was for every line in that breach collection. So every single line would have a password mask, and then we would end up with 789 million password masks. So whether it contains digits, contains lowercase, uppercase, and specials, they're all Boolean values. So all this data, it was parsed out and converted into JSON, uploaded to Elasticsearch, and then queried with Kibana. That makes sense. So as you've probably seen a million iterations of these, this is the top 10 passwords based on this piece of research. And as you can see, very, very familiar. Whenever you look at a top 10 password list, you will find many of these passwords contained within them. And most years have most of these in there because it doesn't tend to change that much year on year. We've still got the #1 password is literally just digits, 1 to 6, 1 to 9, QWERTY passwords, you know, the standard terrible passwords that people set. We've also got top 10 passwords of varied lengths. So this is where things get a little bit more interesting if you're a person like me. And what we can see here is quite standard keyboard patterns laid out in most of the lengths have forms of keyboard patterns in there. And then you have anomalies like this one here, 3RJS, 1L, and so on. That's an anomaly. I had to research why that would be part of this. And I was quite confused as to why that would be there and why there would be so many people with that password set in these files. And what you find when you look at these things is people love keyboard patterns, and across the whole data set, you find that most of them are just standard patterns across your keyboard. And whether that's obviously just a way for people to remember passwords, I don't know. It's a really bad way to set them. And as for the anomalies, so the password that was laid out like this, again, if you look at your keyboard, there's no pattern there. It's quite a random password. There's no pattern involved there. And what I found, and Graham Cluley, if I haven't destroyed his surname there, he believes they're created by bots, and I would agree with him there. Simply because if you look at how the emails are laid out, as well as the passwords, they seem like the bot spammy type email accounts there. They've all been set with the same password for whatever reason. I'll let you guess on that one. So the top 5 domains, these are the top 5 domains based on all of the 789 million. So Yahoo's at the top, Hotmail, Gmail, Yandex.ru, and then the other domains make up 42%. So password masks. So this was the bread and butter of the research essentially. And what this was for is I wanted to see if these masks were any good. Obviously, Morphos Labs had said they are, and essentially I wanted to have my own data set which I could create the masks from, upload more passwords, and see if these masks are any good. You can imagine they were good. So in order to evaluate the effectiveness, we compared the masks to other password masks which are used by professionals. So the Kraken was done with exactly the same machine configuration, GTX 1080 Ti. Again, if I had more hardware available, that would have been fantastic, but unfortunately I never. And we had tested the effectiveness using the LinkedIn breach. So it was 6.5 million unsalted SHA-1 passwords, and essentially we just ran it against that. So that's just a little breakdown of the command breakdown. So we took 60 masks from each data set, so from RockU and exploit.in. Again, smaller data set, larger data set as well. But RockU, the reason I chose RockU is because people tend to go to that naturally anyway, especially people who haven't really done much of this in the past tend to navigate towards the RockU data set. And again, the RockU password list is baked into most penetration testing operating systems now. So we tested the effectiveness and it was around about 10% better. Now, this would change if you incorporated rule sets into it as well. So obviously you can change out the purpose of rules is you change maybe like a letter to a capital letter, change numbers, you do leet speak, things like that. So if you apply that alongside the password masks, you would likely get a much, much higher percentage of the password masks being cracked. So the conclusion to this and future work. So the ELK stack is great for analyzing massive password dumps. It's really good. It works really well. And because of the way Elasticsearch works, it makes the querying much more simpler. Kibana is a great visualization platform. Again, it comes with the machine learning aspects as well, if you wanted to go into that side and use that as well. So passwords masks created using this method are powerful. The masks have not been tried, as I said, with the rule sets because it's very expensive, like computationally. It takes a long, long time just to run the masks themselves. So if you add the rule sets to them, it's many trillions more attempts. So you're always limited by the hardware available, unfortunately. Now moving on to Sencode Breaches, which was the title of this talk. So this platform is something I've made, a little bit of a pet project of mine. It was launched around 3 months ago. I've just released version 2. Last night, actually, I've just released version 2, and it helps feed my obsession with passwords and data breaches. It currently contains all of the Have I Been Pwned breach data. So that's currently all the data that's in there at the minute. But I am planning on filling it out with many, many more data breaches once I've found reliable data sources. Again, Have I Been Pwned is a really good data source, so that's why I've loaded that into it already. So you can, I'm going to show you that in a minute. So why I made it. So it was a personal mission to have my own data breach database. The media as well, they do a terrible job when it comes to reporting on data breaches. They often focus on sensationalism, and that's not good. And instead of the facts. And data breach information should be easily accessible and, most importantly, easily digestible. So that's one of my goals for this project, was to display the data in a nice way. It's easy, readable for people, and you just get the point of it when you view any breach. And then there's the timelines. So this is what happened, when it happened, and how the company responded as a result. That's another important part of why I made this. I wanted to have timelines for every breach. Now that's no easy feat. It doesn't take. It takes quite a lot of time to take hundreds and hundreds of data breaches and have an accurate timeline for it. So currently we haven't started that aspect of it. Although it's on the website, we haven't actually started filling in those timelines yet. We just need the time to go through it. But that will be coming in the next couple of months. So what it does not do, So unlike Troy Hunt's Have I Been Pawned, it only stores the details of the breach. So unlike the way that system functions, it's completely different. It doesn't store the hashed passwords or anything like that. It doesn't store any personally identifiable information. And it doesn't increase government competence in handling COVID-19. That's a really critical point of it as well. So a couple of pieces of software that we're producing, again, none of these are paid for. We've got our data breach database, which is live. I'm going to show you that in a second. Our Argus reporting tool, which is a pen testing reporting tool, and our e-learning platform, which is also being developed. So there's three pieces of software that will be interesting in the future. So I'm just going to bring up the platform. So this is Sencode Breaches. Again, you can search, you can type your email address in there. I'm not going to type mine in, but you can type your email address in there. It'll tell you whether you've been part of data breaches. That uses the Have I Been Pawned API for that. So I'm not storing that information. I'm not storing the email address information. So if we go over to all breaches, some statistics over time. So back in 2007, one breach, and then it goes all the way up over the years. And as you can see, many hundreds more data breaches. This will change dramatically over the next month or so as I find more data sources and start loading them into the system. The Have I Been Pawned data set is really reliable, solid data set, which I've used to load it in, essentially to test the platform and everything else. So we have our search function at the top, keywords, standard stuff for a search form. You can navigate through them just through the pagination if you want to. But if we take a look at one of the breaches, just choose one at random, click one here. So it'll give you the description of it, the nice logo as well. What domain was breached, so you can go to that. Whether it's verified or fabricated. The events are actually timelines. So as we fill those out, that number will go up. When it occurred, when it was added, the breach counts, how many accounts were breached, and the data types, which is really important, just to be able to easily view those. So that's a bad example because it's only got 2 pieces on there. If we go on this, for instance, there's a lot there. Again, there's issues that I'm still ironing out with it and everything else, but it'll show you a list of all the data types involved. So it's email addresses, IP addresses, names, passwords, usernames, etc., etc., etc. So yeah, that's pretty much it in terms of everything I wanted to cover. There's also a statistics page if you wanted to take a look at that. But yeah, that's it for the platform. So I'm happy to hear any feedback. I am looking for feedback, early adopters, people who think that they can give me some advice or any feedback they want to give me. That's absolutely fine. You can pop me an email or go on LinkedIn, add me, and send me a message. So that's it from me. Any questions, just please let me know.